Hey there, algebra. We are in lesson 23. We are still graphing inequalities, solving problems with inequalities in two variables. If you remember, one variable is just a number line, pretty simple. Two variables, we have linear equations, where our solution in two variables is never nice and neat. It's more like a graph. You can't give me a solution in two variables a full solution that doesn't have a graph involved. You can give me ordered pairs that are a part of the solution, but that's really it. All right, so this beginning one says use graphing technology to graph the solution region. To graph the solution region of each inequality and sketch each graph. Adjust the graphing window as needed to show meaningful information. Hold on, let me plug that thing in. So normally we would use Desmos, but Desmos isn't very useful outside of your computer, and everybody has a graphing calculator. So I'm going to show you again and again how to use it. All right, so use graphing technology. So you're going to go to your graphing calculator and hit y equals. Okay, and clear that, whatever, if you have an equation in there, hit clear. So here we have y is greater than x. So we're going to type y equals x, and this right here, we can change what our line looks like. So this is going to give us a line. In fact, if I hit graph, you'll see just a line, y equals x. Now we want to graph y is less than x. So I arrow over. So now I'm flashing right here. Oops. Now if I hit the enter key, it's going to change what my line looks like. So now I have a thick line. I am greater than, less than, funky little dots, hole, and dot, and then back to, well, a dashed line, then back to the beginning. Okay, so we want greater than, so we're going to make it look like that. Now you may have a different type of graphing calculator which has different symbols in that area, and we can talk in class if you're not sure how yours is supposed to work. So here we have this one. Now if I come over here, we're just going to hit a highlighter because so that's what the solution looks like. And actually, that's not what the solution looks like. It's most definitely a dashed line because it's just greater than. Okay, here we have y is greater than or equal to, so we will have a solid line with everything shaded above it. All right, now let's go over here and do the y is less than 8. Now I can't do a less than versus less than or equal to in our graphing calculator. You just have to know the difference. So let's go over here and we're going to do -8. And it's less than, so there we go. Okay, so now we're coming down here, -2, -4, -6, -8. So when y is less than -8, we get a dashed line here, and we're shading below it. This is the y equals graph, so on the y-axis, y is -8. So everywhere on this dashed line is y is -8, and so we're less than, we go underneath it. Okay, here I can't graph, well, I actually want to flip all of this stuff because how my graphing calculator works. So Pac-Man's eating the y, I'm going to keep Pac-Man is eating the y, -x plus 8, and type that into my graphing calculator. So -x plus 8. Come over here to the shading, and I am greater than, and graph. Uh-oh, what did I do? go to. Oh, that is the wrong negative. I do that often in my simulator here. Okay, so our y-intercept is 8, 2, 4, 6, 8, and we're shading down. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 2, 4, 6, 8, and it's greater than or equal to, so solid line, and we are greater than, so we're shading above. All right. Now here, this next one, our window is going to need to be changed. So we are 10x minus 200. If I hit graph, let's see, we're less than, so let's come over here and change the shading. Hit enter, less than. If I hit graph, I'm not going to see anything because my y-intercept is negative 200 and my slope is 10. So I need my window to reflect that. So my x-min, we're going to leave the x-axis alone just for a minute, but let's look at our y-axis. If my y-intercept is negative 200, I need my y-axis to have negative 200 in my window. Try to keep things symmetrical for now. Let's just keep it in a nice square. Now our scale means all those tick marks, these right here. I don't want them to go by ones when I go from negative 210 to positive 210. So let's just do by, I don't know, 20s. So every tick mark is going to be 20. Let's see if that works. Not bad. Okay, you can tell we're down there somewhere. Just going to make that just a little bit bigger, see if it helps. Not bad. Okay. X equals 0. Wondering where it crosses the x-axis. It's my x-intercept. Somewhere around 20. Okay. So when that equals 0, let's see, when y equals 0, 20. So let's do 20, 40, 60. And we're going to have negative 1, well, it's a negative 50, negative 100, negative 150, negative 200. So we're crossing the axis here and here. And we're less than, so we need a dashed line. It's beautiful, I know. And we're less than, so we want to be underneath. All right. Now this one, I can't plug that into my graphing calculator as is. I definitely need to do some rearranging. So I'm going to write it down here because I'm out of space. 2x plus 3y greater than 60. I need to move the 2x to the other side. I have 3y greater than negative 2x plus 60. Let's divide everything by 3, all the pieces and parts. So my equation is y greater than negative 2/3, keep it in a fraction, plus 20. So let's try that. I know this is taking way more time than it usually is. So I'm going to put some parentheses in there because I want my slope to be all connected. Negative 2/3 x plus 20. Okay, my window's not right, but let's just see what happens. And we're actually greater than. Takes so long. There we go. Okay, it looks fine. I know my y-intercept is 20. So really if I do this, let's do 10, 20, 30. So my y-intercept is 20 and my slope is negative 2/3. So if I go down to over 3, that'll give me a pretty good idea. And I'm greater than, so I want a dashed line, and I'm shading above. Okay, that was awesome. I want to show you that last one in Desmos, because I know some of you guys like Desmos. Takes a second, sorry. Might be a little bit of a longer video today. That was, and with Desmos I don't have to change anything. I can just say 2x plus 3y is greater than 60. Okay, can't see it at all. So we have to zoom out. And that's exactly what we drew here. It looks a little neater, but it is exactly what we drew. In fact, it is exactly what we see here also. All right, good job. I hope you're getting more confident with your graphing. Let's make that smaller. Move my head, and let's get back to our lesson. All right, so solving problems with inequalities and two variables. Here are 3 situations. There are 2 questions about each situation. For each question that you work on, write an inequality to describe the constraints. Specify what each variable represents. Use graphing technology to graph the inequality. Sketch the solution region on the coordinate plane and label the axis. Name one solution to the inequality and explain what it represents in that situation. And then answer the question about the situation. Okay, so we have one on bank accounts and concert tickets. All right, and advertising packages. Okay, a lot of work here. And not that, are you ready for more? And then this card sort we will do in class. All right. And that is it. So really, we're going through those situations. And that's it, all right? So, a customer opens a checking account and a savings account at a bank. They will deposit a maximum of $600, some in the checking account and some in the savings account. They might not deposit all of it and keep some money as cash. Whew, it's a lot of information. If the customer deposits $200 in their checking account, what can you say about the amount they deposit in their savings account? So first, write an inequality to describe the constraints. So I want to do x plus y is a maximum of $600, where x equals money in checking account, y equals money in savings account, so here I'm going to write, I can't write sideways, it's too hard. Checking, I did that backwards. So y is savings, x is checking. I know my x and my y-intercepts are 600, so let's do 1, 2, 3, 4, 5, and 6. Put a dot. 1, 2, 300, 400, 500, 600, and put a dot. We are less than or equal to. Oh, so I want a solid line. And we're shading everything underneath. So graphically there is my solution. So I have my equation. What do my constraints represent? My graph with my x and my y axis labeled. I did not use graphing technology. sketch the solution, name one solution. Okay, I'm going to pick an ordered pair and say 150, 250 represents a possible solution, which means I have $150 in checking and $250 in savings. And then answer the question. If the customer deposits $200 in their checking account, anywhere on that dashed line, what can you say about the amount they deposit in their savings account? If they deposit, it says they might not deposit all of it and keep some money as cash. So if they deposit $200 in their checking account, they can have anywhere from $100 to $400 in their savings account. So if they deposit $200 in their checking account, they can have anywhere between anywhere between $0 and $400 in their savings account. How I would write that with an equation, I would say y could be less than or equal to 400. Knowing that y has to be positive, I could also say 0 less than or equal to y less than or equal to 400. Okay, either one of those works perfectly well. Okay, it is a possible solution, even though if I added those together, 250, 300, that's only $400. That means they have $200 in their pocket. So that is just $400 in the bank. All right, let's move on. The bank requires a minimum balance of $50 in the savings account. It does not matter how much money is kept in the checking account. So here I've got y is greater than or equal to 50 because y is my savings account. Okay, I have my y-axis, my x-axis. Sorry, that's checking. This is savings. We're going to make these a little bit bigger. This is going to be 100, 200, 300. And then 100, 200, I think that's wrong. 100, 200, yeah, 300. So if y is greater than or equal to 50, that's right here, my answer can be anywhere above that line. If the customer deposits no money in the checking account, but is able to maintain both accounts without a penalty, what can you say about the amount deposited in the savings account? Well, first let's do all of our questions. There's my equation, and y equals money in savings. I have my graph. And then if the customer deposits no money in the checking account but is able to maintain both accounts without penalty, what can you say about the deposited, we've got our A question answered. We've got our B question answered. What is C? Name one solution. There we are. We're going to say right here, I actually have, our C question is, I think that's 150, comma 100. I have 150 in checking and 100 in savings. Which I go back to the question, that ordered pair does fulfill my constraints. And then D was answer the question. Okay, we're getting to the question now. Oh, and it skipped back. I hate it when it does that. There we go. If a customer deposits no money in checking but is able to maintain both accounts without penalty, what can you say about the amount deposited in the savings account? That means they deposited at least $50 in savings. All right, let's move on to our concert tickets, except it jumped again. 2 kinds of tickets to an outdoor concert were sold, lawn tickets and seat tickets. Fewer than 400 tickets in total were sold. So we've got lawn tickets plus seat tickets were less than 400. Okay, where X equals lawn tickets and Y equals seat tickets. So we have lawn and seats. We always get the lawn tickets if we go to concerts. I just enjoy it more. So 100, 200, 300, 400, 100, 200, 300, 400. I'm going to get a dot here and a dot here, and we're just less than, so I want a dashed line, and we are definitely shading below. So we have A, B, C, give me an ordered pair. I can say 100, 100 means 100 lawn tickets were sold and 100 seat tickets were sold, and the concert was not full. So if you know that exactly 100 lawn tickets were sold, what can you say about the number of seat tickets? So if I know exactly 100 lawn tickets were sold, I can say the seat tickets were less than 300, okay? It can be anywhere in this shaded area. So if exactly 100 lawn tickets were sold, the number of seat tickets is less than 300. Okay, that's our D question. Lawn tickets cost $30 each and seat tickets cost $50 each. The organizers want to make at least $14,000. I always know that side, right? And then I've got $30 for lawn tickets plus $50 for seat tickets. Another reason we always sit in the lawn, it's cheaper. There's our equation, where it's the same thing, X equals lawn and Y equals seats. And if I graph it, lawn, seat, I'm going to use the same 100, 200, 300, 400, 500, 600, 100, 200, 300, 400, 500, 600. All right, my XY axis is a little different, so let's go ahead and do it. Figure out what our y-intercept is and our x-intercept. If I put in 0 for x, and then I divide both sides by 50, 14,000 divided by 50, I get 280. And then if I put 0 in for y and divide, I get a fraction, 466 2/3. Oops. So my y-intercept is 280, and my x-intercept is 466 2/3. We cannot sell 2/3 of a ticket. We know that. All right, so 450, 66. And 280, 250, 60, 70, 80, right about there. And we are solid line, and we want to shade above. Okay, let's pick an answer right there. Let's say there were 400 lawn seats and 450 seats. So that ordered pair means 400 lawn seats and 450 seats. So I can do X was $30. Oh gosh. 30 times 400 plus 450 times $50. And that is more than 14,000. So we're good. All right, so that last question, if you know that exactly 200 seats were sold, what can you say about the number of lawn seats? So 200 seats, that means the number of lawn seats are in here somewhere. So that means that there were X is greater than 100. And we can find out exactly, because I think the 100 is not going to be accurate. So let's not do that and figure it out exactly. So 30x plus 250 times 200 is greater than or equal to 14,000. $50 times 200 is 10,000. So I have 30x is greater than or equal to 4,000. And x is greater than or equal to 133 1/3, which is not possible. So we need x greater than 134. Which makes sense. Like, my graph is just not that accurate. All right. I hope you're enjoying these. I think they're kind of fun. All right, an advertising agency offers 2 packages for small businesses who need advertising services. A basic package includes only design services. A premium package includes design and promotion. The agency's goal is to sell at least 60 packages in total. So at least 60 packages in total means that we are selling x plus y is greater than or equal to 60, where x is basic and y is premium. So basic and premium. They have to go to 60, so 10, 20, 30, 40, 50, 60, 10, 20, 30, 40, 50, 60, dot here, dot there. We're a solid line, and we need greater than or equal to 60, so above this solid line. B is, I think, pick an ordered pair. That works. Let's go here. That means if we sell 40 basic and 40 premium, we have sold greater than or equal to 60 total. I think that was question C. And then D, if the agency sells exactly 45 basic packages, what can you say about the number of premium packages it needs to sell to meet its goals? So if we go 45, hold on. Okay, I thought somebody was coming. If we sell exactly 45, what does it say about the premium packages? So I think we would need 15 or more. And my graph is off. So yeah, we would need at least 15 premium packages. 60 minus 45. Yep. Our Y would be greater than or equal to 15 packages. We would need to sell at least 15 premium packages to meet the goal. Okay, the basic advertising package has a value of $1,000. And the premium package has a value of $2,500. The goal of the agency is to sell more than 60,000. Worth of small business advertising packages. Okay, so there's our nice equation. X is still basic, Y is still premium. Let's graph it. This one's a little bit ickier. Let's go here actually. You've got that written down. Let's have a little bit of fun. I did not write mine down. There we go. 2500Y is greater than 60,000. All right, so we see our x-intercept and our y-intercept. Okay, Desmos is fantastic, isn't it? $60 and $24, 10, 20, 30, 10, 20, 30, 40, 50, 60. Yep. Okay, we are dashed. That's awful, I'm sorry. Now I'm rushing because I have to be somewhere in 3 minutes. So that's dashed. And we're greater than, okay, let me talk about that dashed versus solid again. Basic advertising package, more than 60,000. Okay, so this should be just greater than 60,000, not greater than or equal to. Okay, if you know that exactly 10 premium packages were sold, how many basic packages do you need to sell? So this would be 25,000. $60,000 minus 25,000. $35,000 divide by 35. So X would have to be greater than 35, which would make sense here. We sold 10. Sorry, X was basic. Y was premium. I got a little. We sold 10 of these. So if my graph were drawn correctly, it would have to be in this range. Okay? All right, like I said, we're not going to do the Are You Ready for More, and we're going to do our card sort in class. Okay? It'll be great. All right, good job today.